back to Hardcode. In this video, we're tackling the challenge missing numbers. This puzzle not only tests our coding skills but also delves into the mathematical operations and bit manipulation. Let's dive in. So, given an array nums containing n distinct numbers in the range 0 to n, return the only number in the range that is missing in the array. So the question is very straightforward. We just need to return the missing number in the given range. So example 1, here we have nums as 301 and the range is n 0 to n, which is 0 to 3, and only 2 is missing, so we return 2. Similarly here the range is 0 to 2, only 2 is missing, we return 2. And here the range is 0 to 9, only 8 is missing in this, so we return 8. So constraints are n lies in the inclusive range of 1 to 10 power 4 and the elements of the array are in the inclusive range of 0 to n. So they said that all elements are unique in this. The follow-up is, could you implement a solution using only O of 1 extra space complexity and O of n runtime? Yeah, we can do this. So here approach 1 is using summation. So the idea is to calculate the expected sum of 0 to n and subtract the actual sum of the array from it. And then the missing number is just the difference between these two. So the steps are like, first we need to calculate the expected sum. This can be done using the formula n into n plus 1 by 2, and we calculate the actual sum. We just need to iterate over the array and calculate the sum of all the elements. And then the missing number, which is just the difference between the sum and the actual sum. So here let's take this example of 301. Here the expected sum is n into n plus 1 by 2, so 6, and then the actual sum is 3 plus 0 plus 1, which is 4. So the missing number is 6 minus 4, 2. We can see the 2 is missing here. So let's look into the code here. So here we're just initializing the n with the length of nums, and then expected sum is n into n plus 1 by 2, and then here the actual sum is, we're using the equality function sum and then finding it, and then we just retain the expected sum minus actual sum. So here the time complex is O of n, where n is the number of elements in the nums. Here it's O of n because we iterate all over the elements and find the sum. That is then within the sum function here. The space complexity is O of 1 because here we don't require any additional space that scales with the size of the input. Regardless of the array size, we only need a fixed number of variables to hold the intermediate results. So it's a constant space and not increasing with the length of array. So that's why it's O of 1. Approach 2, bit manipulation using XOR. So here the idea is, in the given range we XOR all array elements with their index. Since the XOR of a number itself is 0, we'll be getting the number which is missing in this range. So step 1, we just initialize the variable XOR sum, and then we XOR this with the index and the value, and then we return XOR sum. So let's look into the example here. So for the XOR approach, we take the same array as example, and here we initialize the XOR sum variable with 3, which is length of the array. This is because the loop index is only from 0 to 2 and we have to take 3, right? So we just initialize it to the XOR sum, and then for each iteration what we do is we XOR sum with index and element. So in the first iteration it would be 3 XOR with 0 and XOR with 3, that is 0. This is because the fundamental is A XOR 0 is A, and then A XOR A is 0. See here in the iteration 2 we get this result, and then we have it here in the, so 0 XOR 1 and XOR 0 is 1. So here we get this and we have it here, and 1 XOR 2 XOR 1, which is 2. So the result of after all iteration is 2, which is the missing number here. So let's look into the code here. We're just initializing the XOR sum with the nums because we need to have to consider the inclusive range of nums. So here we're just using the enumerate function to get the index and the element, and then we just doing the XOR operation, and then we return the XOR sum. Here the time complexity is O of n and the space complexity is O of 1. So demo. So I have the code ready here. Here I just defined the two methods for the two different approaches. Let's try submitting each of this. First let's submit using the summation approach. And then it's accepted. Let's submit XOR approach. This was accepted solution. So to wrap up, we delved into the two efficient solutions for missing number problem. Mastering these techniques not only helps in solving this problem but also enhances our understanding of fundamental concepts in coding. So keep practicing and exploring new strategies to level up your coding skills. Thank you for tuning into this episode of HackCode. If you found this video helpful, be sure to give it a thumbs up and subscribe to the channel for more coding tutorials and problem-solving tips. If you have any questions or suggestions for future topics, feel free to leave them in the comments below. Until next time, happy coding.